Hello and welcome to this lecture on the Linux terminal in depth. When someone starts to learn Linux, the first words he will hear about are command, console, or terminal. At first sight, they seem intimidating, especially for a complete beginner. But rest assured that at the end of this lecture, you'll know in detail what they are and what they do. Linux is an operating system highly oriented towards commands. Even though there are many graphical interfaces available, any effective Linux administrator will prefer running commands for different administration tasks. This is what makes Linux so powerful and flexible. There are hundreds of highly efficient commands, and knowing how to use and combine them makes you a highly efficient sysadmin. Let's see what a terminal is. It is actually called a terminal emulator and is a crucial part of any Linux system because it basically allows you to access the system through a shell. It's a program that opens a window and lets you write commands. There are a bunch of terminal programs available, but the most used one is the GNOME terminal, which is the default terminal in Ubuntu and CentOS. Other terminal emulator applications are Console, Xterm, Quake, or Terminator. Let's open the GNOME terminal. Go to Show Applications on the dock and search for Terminal. This is the GNOME terminal. Another quick way to open such a terminal is to click on the desktop with your right mouse button and then select Open in Terminal. Or the shortcut used to open a terminal is Ctrl, Alt, and T. I have started more than one terminal. Note that you can start as many as you wish as new windows or new tabs in the same window. If you want to start a new terminal in a tab, just click on this plus sign. In this window, there are 3 terminals running in 3 tabs. But what is a shell? Simply put, a shell is a program that takes commands from the user through the keyboard and gives them to the operating system's kernel to get executed. It's also called the command interpreter because it accepts commands from the user and then checks or interprets them to see if they are syntactically correct. And if they are, the shell will send them to the kernel for execution. The shell gets started when the user logs in a console or starts the terminal. In this terminal, the default shell was started. In this example, I've started a few terminals, and in each terminal the default shell has started and is waiting for the commands. I'm executing a few different commands. An important thing to know is that Linux is a case-sensitive operating system, which means that it's sensitive to the capitalization of letters. This is different compared to Windows, which is case-insensitive. From now on, we'll consider the commands and options as written in lowercase letters if I don't specify otherwise. So if I say run the IP address command, without specifying the case, it means the command should be written in lowercase letters. Let's get back to the shell. Imagine that any Linux command you want to execute, from a simple file copy operation to a full system upgrade, should be written into a shell, which in turn will check to see if the command exists and is syntactically correct before sending the command for execution. For example, this command .sa doesn't exist. There are several shells available, but the most widely used one is called bash. It is the default login shell for many Linux distributions, including Ubuntu, Linux Mint, Debian, CentOS, and macOS as well. If you run Windows subsystem for Linux or WSL on Windows 10, Bash is also the default shell. Other shell applications besides Bash are Bourne Shell, C Shell, Korn Shell, or Z Shell. In this terminal, the Bash shell was started. We've discussed terminals and shells, but didn't say a word about consoles. What is a console? The console is a special sort of terminal that starts if no GUI was installed, so the terminal and the console are similar. You start a terminal in a graphical interface and the console in a text-only interface. Modern Linux systems provide more virtual consoles. These are usually accessed through key combinations, which are Ctrl, Alt, and F1 to F8. So there are 8 virtual consoles, but one of them is already used if there is a graphical interface that has started when you've logged in. However, if you installed Linux in VirtualBox, it may be possible that the key combinations will be caught by the guest OS, not by the host OS, and won't work. Let's recap in a nutshell. The terminal is the graphical application where the default shell will start. This is a terminal called GNOME Terminal, and the default shell, which is Bash, has started. In the shell, which is the command interpreter, I can write commands and the shell will send them to the kernel to get executed. And finally, a console is like a terminal but is started in a text-only environment where no GUI or graphical user interface was installed or started. Note that in Linux world, at the keyboard, the shell, the terminal, and the console can all look pretty much the same from the user's point of view. Many times the terms terminal and console are used interchangeably. It's common to say, I run the command at the console, even though the command was typed in a terminal. Note that the GNOME terminal is not the only one. I'll install a new terminal emulator called Terminator, which provides several features that the default terminal application does not support. A useful feature is the ability to create multiple terminals in one window. So, in the GNOME terminal, I'm writing sudo apt update && sudo apt install Terminator. It's installing the Terminator. Sorry, I've misspelled it. It's install written with double L. I'm confirming it. It's done. And I'm adding it to the dock as a favorite application. Terminator and add to favorites. I'm also adding the default terminal to the dock. This is the Terminator. I'll also change the default theme to a lighter one for you to see it better. This is better, at least for recording. And if I want another terminal in the same window, I'm just clicking with the right mouse button and then split horizontally or split vertically. And I have two terminals. Linux comes with hundreds of commands, each of them with lots of options. It's impossible even for an experienced Linux administrator to remember all the commands and their options. Fortunately, Linux comes with its own help built-in system. In this lecture, we'll be talking about man pages. Man is short for manual and a man page is simply the documentation of a program or command. You can use the man command to read the documentation of a specific command. To open the man page of a command, you type in the terminal man and the command's name. Let's open the man page of the ls command. I'm writing man ls. By default, man uses a program called less to display the output. While you are in the man page, you can get additional help by typing the letter H. I've just typed H. You see this title, Summary of less commands. This means that the man command used the less command to display the help. For a beginner it could sound weird, but there's a command called less used to display the contents of the text files. It's a viewer or a pager. To get out of this screen, you press Q, and to exit or to get out of the man program, you press Q, which comes from quit again. Let's open the man page of ls again and see what is its main structure. You'll find the same structure for all man pages. The first line contains the name of the command you are reading about, along with a very short description. Then comes the synopsis of the command, which provides a formal description of how to run it. In this example, we run it as ls, some options, and some files as arguments. In a man page, everything that appears directly before three dots, which are also called ellipses, can be repeated. So you can repeat different options and also file names. This means that you can specify more than one option or file. Options and arguments are put between square brackets to indicate that they can be left out. They are not mandatory. This is the case of ls. We can run it both with or without options and arguments. Other conventions used in man pages are: when you see bold text, you are supposed to type in exactly as seen. But when you see an underline or italic text, you need to substitute it with something appropriate. Here we don't write size, S-I-Z-E, but we have to specify the size, the actual size. After the synopsis, a longer description of the command is given together with all its available options. When you see an option in short format, a comma, and an option in long format, it means that you can use any form you wish. Note that some man pages contain an extra section called options, where the options are explained. Take a look at the man page of the df command. This is the options section. At the end of the man page, there are the author, the copyright, and see also sections. Let's go ahead and talk about the navigation within a man page. Let's see the most important navigation keys. Use the arrow keys to move a line up or down. Up and down. To forward one window, press on Ctrl and F or on the space key. I'm forwarding one window. I'm at the end. And if you want to move backwards a screen or a window, you press Ctrl and B. I'm moving backwards. And to go to the very beginning of the man page, type lowercase g. I'm at the beginning. And to go to the very end, type uppercase G. I'm at the end. Sometimes you want to search in the current man page for a specific option. Let's say we are in the man page of ls and we want to find matches for sort within that manual page. First, I'm going at the beginning, so I'm pressing G. What I'll do now is write a backslash and the string I want to search for. Sort. And I'm hitting enter. Any matches in the current man page will be highlighted. You can then navigate between matches with N, like this, or Shift N, or uppercase N. N will take you to the next match, and Shift N, or uppercase N, will go to the prior match. So backwards. When you search using a forward slash, the searched term, it is searched forward. But if you are, for example, at the end of the man page, so I'm pressing an uppercase G to go to the end, and want to search backwards, then you type a question mark and the searched term. Or -U. I was searching backwards for -U, and it found a match which says that the option is used not to sort file entries. Okay, those were the most important things about man pages that I think you should know. Also note that there are two types of commands in Linux. Commands that are executable files on the disk and shell built-in commands. The last ones are built into the shell, and most of the time they don't have a dedicated man page. I'm quitting, pressing Q. To check if a command is an executable file or a shell built-in, use the type command. So type df. It's displaying the path to the command. Or type apt. All these commands are executable files and have their own dedicated man pages. But commands like cd, alias, or umask are shell built-in and do not have a dedicated man page. All these commands are shell built-in. To see the help of such a command, instead of man, use the help command and the command name. So help cd. And you see its help. So cd is used to change the shell working directory. Note that you can use the help command only for shell built-in commands and not for commands that are executable files on the disk. So help ls is not working. But another way to get some help is to write the name of the command and --help. This is available for both shell built-in and executable files commands. So rm --help or ls --help or cd --help and so on. I'll introduce you a new command which is ifconfig. This is used to both display information about the network interfaces and configure them. If you want to see the IP or MAC address of a network interface, you have ifconfig at your disposal. ifconfig belongs to NetTools package. If, when running ifconfig, it says command not found, then you should first install the NetTools package. Run as root on Ubuntu, apt install NetTools. So sudo, the command will run as root, apt install NetTools. Or on CentOS, dnf install NetTools. Sudo dnf install NetTools. On CentOS, it's already installed. And a final trick I'd like to give you is how to search for a command, feature, or keyword in all man pages. To do that, use man -k and the keyword you are searching for. Let's say man -k ifconfig. Or man -k uname. You can also pass a string enclosed in double quotes as argument. Man -k copy files. It will search for the string copy files in all man pages. And it found 3 commands. Note that man-k is similar to the apropos command. So apropos and the command ifconfig, or apropos uname, x the same. In these examples, it has searched for ifconfig respectively uname in all man pages and has displayed the commands that contain references to the searched keyword. Now, if I want, I can check the man pages of those commands to dive deeper. Let's go ahead and discuss the structure of the Linux commands. To give a command to a Linux system, you type in a shell the command's name, its options, and arguments if required. Let's get started with an example. I'm opening a terminal and the default shell, which is bash, was started. And I'm running ping -c1 8.8.8.8. As you probably already know, the ping command, which is available on Windows and Mac as well, is used to test the network connectivity to a destination host. For the moment, please don't focus on the actual command or on what it does. We'll have plenty of time to dive deep into each important command. Just focus on the structure of the command line and how I put things together. We notice that we have an active connection to 8.8.8.8, which, by the way, is a public DNS server from Google. This is how we check that the internet is working. If you have any issue with your internet connection, to continue with this example, you can ping your loopback interface IP address, which is 127.0.0.1. This is the IP address of your loopback interface. It will work even though you don't have an active network connection. Let's take a closer look at the command line. The name of the command is ping. C is one of the command's options, 1 is the options value, and the IP address, which was 127.0.0.1, is the command argument. It's important to know that all options are preceded by a hyphen, a minus sign. Note that the command name, its options, and arguments are always separated by one or more white spaces. In fact, the shell knows that the command name ends where it sees the first white space. The command name has ended here, before -c. Note that it's common to separate the command name, its options, and arguments by one white space, but there's nothing wrong if you write more white spaces. This is correct as well. It's fairly standard that the options must come after the command name and before any command arguments. However, there are variations and commands that permit options after the main argument, like this. I'm removing -c1 and I'm writing it at the end, -c1. By the way, it means that it will send only one ping packet to the destination. This is the same, but it's not common. In the examples of this course, we'll follow the standard and we'll write the options after the command name and before its arguments. In Linux, there are commands that require some options or arguments and return an error if they are run without arguments. And there are other commands that do not necessarily require options or arguments. For example, if I run the ping command again, this time without any option or argument, I'll get an error. It says destination address required. It's mandatory to specify an argument. But if we take another command, say ls, we'll see that we can run it both with and without options or arguments. By the way, ls is probably the most used Linux command. Its name comes from list and it displays or lists information about the file system. In this example, the ls command has displayed the contents of the current working directory. Now, let's run it with an option and an argument. -l option tells ls to use a long listing format, and /etc, which is the argument, indicates what directory to list. Using the options, we change the command's behavior. Note that some options can be written using a hyphen or a minus sign and a single character such as -l or double hyphens and an entire word. So ls --all and ls -a are similar. It's the same command. By the way, this option -a or --all will display the hidden files and directories as well. Note that we can use more options, not only one. In this example, I'm using both short and long options. And it's common to group all short options together like this. See how I've grouped the L and H options together. The last two commands have the same effect. They are equal. Let's see one last example. I'm running a command without any option. df. The same command with a single option in short format. The command with two options. Sorry, the command is df. Or I can group the options. I can also add a third option in long format. By the way, the df command displays information about the file system and the disk space usage. Okay, that's all about the Linux commands structure, options, and arguments. This lecture is really important if you're a complete beginner. Take your time to deeply understand each concept and rewatch the video until you feel confident about it. A Linux administrator spends most of his work time in the terminal. In this lecture, I'll show you a list of useful bash shortcuts that every Linux admin should know if he wants to get things done faster. Let's get started. Ctrl and L clears the screen. If there's anything on the screen, you can clear it by pressing Ctrl and L. It's similar to running the clear command. Ctrl and D closes the bash shell. It's similar to running the exit command. I'm pressing Ctrl and D. The shell was closed. I'm opening the terminal again. You can also type exit. Ctrl and A moves the cursor to the beginning of the line. This is useful if we run a command on a file and then we want to run another command on the same file, like I'm running ls-l etc password, and now I want to run the cat command on the same file. Instead of writing the command again, I can press up the arrow key to recall the last command and then press on Ctrl and A to move the cursor to the beginning of the line. Now I can simply replace ls with cat and run the new command. Of course, I have to remove the -l option, which is an option of ls. By the way, up arrow key retrieves the previous command. If you press it constantly, it takes you through multiple commands in history, so you can find the one you want. Use the down arrow to move in the reverse direction through the history. Another useful shortcut is Ctrl and E, which moves the cursor to the end of the line. I'm pressing Ctrl and D, and the cursor was moved to the end. I can continue writing. Another useful shortcut is Ctrl and U, which deletes all characters before the cursor by cutting and adding them to the clipboard. Let's consider this command, and you want to execute another one. Instead of pressing on backspace multiple times, you could press Ctrl and U. Ctrl U is also useful when you type in a password and after a few characters you realize you made a mistake. I have typed a few characters and I've realized I did a mistake. Instead of pressing on backspace multiple times, I could press Ctrl U. The entire command line was deleted. Let's move on and see another shortcut. To interrupt the process running in the current terminal, press Ctrl and C. Let's say you run a command that takes some time and want to stop it. Then you press Ctrl and C. For example, I'm gonna download a very big file using wget, and after a few seconds I'll decide that I want to stop it. And I'm stopping the command, pressing Ctrl and C. It was stopped. Or another one. Ping and an IP address. Without any option, ping will send packets continuously. I'm stopping it by pressing on Ctrl and C. It was stopped. Note that Ctrl and Z does not stop the current running process as Ctrl C does, but only suspends or pauses it, and it can be resumed later on. I'm pressing on Ctrl and Z. The process was not interrupted, was just stopped. The difference being that I can resume it anytime later. For example, BG %1, and the process was resumed. We'll talk more about these concepts in the process section. Let's talk about bash command history. The bash shell stores in the user's home directory the history of the commands each user has run in a file. The file is .bash_history by default. The number of commands that will be stored in the history file is controlled by an environment variable called hist_file_size, written in uppercase letters. Remember that in Linux, everything is case sensitive. To print the value of a variable, run echo, the $, and the variable name. In this case, hist_file_size. This is the variable. And we notice that this Linux system saves 2000 commands into the history file. You can print out the entire bash history to the screen by running a single command, which is history. I'm running history. These are all the commands saved in history. You are seeing a list of commands in your bash history along with a number to the left of each. The command with a 1 next to it is the oldest command in your bash history, while the command with the highest number is the most recent one. And of course, the most recent command run was history. Note that running the history command does not mean listing the entire contents of the history file. There's another variable called hist_size that controls how many commands from your bash history will be stored in the memory. Let's see its value. And it's 1000. So let's draw a conclusion. Bash will save maximum 2000 commands in the bash history file, in the user's home directory, and maximum 1000 commands in the memory. These are the commands displayed by the history command. So the history command will display only half of the commands saved in the history file. Also note that the history file is updated only when the user that ran the commands logged out. I'm running the command IP address show. The command is displayed by the history. Look, this is the command, but it's not in the history file. It's not there. Now I'll log out. I'm logging in again. I'm opening the terminal again and checking the history file. And the last command is in the history file. To run a specific command from the history by its number, use an exclamation mark and the command number. For example, I want to run the 17th command from my history and I'll type an exclamation mark and the number 17. And to rerun the last command you ran, type 2 exclamation marks. This has the same effect as pressing the up arrow once to view the previous command and then pressing enter. You can also refer to a command from a certain number of lines back in the bash history. For example, an exclamation mark and -7 would run the last 7th command. The command was rm1 and it was an error. Let's try another example. I want to rerun the who command. So, an exclamation mark, -3. And the command was executed. To search for a command in your history and run it, type an exclamation mark and the command name. For example, I want to run the last ping command, and to do that, I'll type an exclamation mark and the command. And I'm hitting enter. And it's running the last ping command. I'm pressing Ctrl+C to stop the ping. Note that this can be also dangerous because you don't know exactly how the command was executed and there's the risk of executing another command. What you can do is append :p to the above expansion and bash will print out the command to the terminal without running it. This is useful if you want to confirm that you've selected the correct command before running it. Like this. It's just printing the command. It's not running it. And if the command is correct, I can run it. Let's move on and see how to walk through the command history. Ctrl and P or up arrow are used to go to the previous command in the command history. Press the shortcut multiple times to walk back through the history. And Ctrl N or down arrow will go to the next command in the command history. Press the shortcut multiple times to walk forward through the history. Bash also has a recall mode you can use to search for commands you've previously run. Press Ctrl and R and start typing a command to search your bash history for it. I'm pressing Ctrl and R and I'm typing PI and it has found the command. When you find the desired command, you press Enter or Ctrl and P to run it. I'm pressing Ctrl and R again, type cat, and now I do not want to run the command. And I'm pressing Ctrl and G to leave the history searching mode and clear the line. I'm pressing Ctrl and G. There may come a time when you want to remove some or all the comments in your history. If you want to delete a particular comment, enter history -d and the line number. For example, I want to remove this comment. So history -d and the line number. The comment was removed from the history. It's not there anymore. To clear the entire contents of the history file, execute history -c. The entire history was removed. It's empty. At the end of this lecture, I have a small homework assignment for you. The command history is a very powerful feature of Bash, and using it efficiently saves you a lot of time. However, there are moments when you want to run a command without saving it to history. Let's suppose you want to copy or view a file you are not supposed to, connect to another machine you are not allowed, and so on. How can you run the command without leaving any trace? Think about it, try different ways to manage that, and even search on Google for a solution. We'll take a short break, and in the next lecture, I'll show you how to do it. For any Linux professional user, the command line is an essential and ultra powerful tool. In this lecture, I'll teach you how to be really efficient when using the terminal. The most important advice I could give you is to use the tab key for auto-completion. This is something you cannot live without. It will not only save you so much time at the Linux command line, but it will keep you from making mistakes as well. Tab is a feature supported by Bash and other shells as well. If you have to remember only one shortcut, this should be the chosen one. How it works is really simple. When typing at the Linux command line, just use tab to auto-complete commands, file names, or folder names. To use this feature, type the first few letters of the command you want to run or the file name you work with, followed by tab. Bash will scan the current directory as well as all other directories in the search path for matches to that name. If a single match is found, Bash will automatically complete the file name for you. If multiple matches are found, you have to press the tab key twice and it will show you all results, and you should continue typing until there's only one match. Let's see some practical examples. In my terminal, I write the letters IFC and press tab on my keyboard. The shell has automatically completed the command for me. Note that the letters IFC uniquely identifies the ifconfig command, and that's why it has automatically completed it. But if I write IF and press tab, nothing happens. Do you know why? Because there's more than one command beginning with the letters I and F, and the shell doesn't know which one I'm referring to. What I can do is press tab twice, and it will display all available commands that start with I and F. And there are two. Then I can continue typing until it can uniquely identify the command and autocomplete it. Let's see another example. Tab is used to autocomplete both the commands and the files or directories. I'm writing cat, a white space, a / and E, and I'm pressing tab. It has completed the etc directory from the root directory, which is / because there's only one directory that starts with the letter E, and that's etc. I continue and type the letters PA and press tab. Nothing happens because there's more than one file or directory beginning with PA, and the shell doesn't know which file or directory I want. But if I press tab 2 times, it will display all the files and directories that start with PA and are in the /etc directory. And there are 5. I'm typing the next letter, which is S, and pressing tab. Now the shell knows what I want and auto-completes the entire file name. By the way, the cat command displays the entire contents of the file at the terminal. Now it's time to tell you something really important, something that in my opinion is the key to not make serious mistakes while working in the Linux terminal. If tab does not complete automatically a command or a file name when it should, then there's a mistake. Do not continue writing the command or the file name, but stop and analyze what you have done up to that point. Tab doesn't complete because somehow, somewhere, there's an error. For example, let's suppose that by mistake, I'm writing a white space before the P letter like this. I'm hitting tab and nothing happens. It would be a mistake on my part to try to write the file name manually. I've got two errors. What I should do is analyze the command line and try to find the error, like this white space here. I'm removing it and then hitting tab, and it completes the file name. Another common mistake is to try to write the file and directory names manually instead of using tab. Let's suppose I want to remove a file in /var/log directory. Like this. rm and the full path to that file. So /var log and the file. A random file, it doesn't matter. I won't remove it anyway. Don't focus on the rm command, which is used to remove files and directories, because we'll have plenty of time to talk about it later in the course. Instead of using tab auto-completion, like I actually did, I write the path manually. There's the chance that by mistake, I'll write a white space before the file name, like this. The effect will be that the rm command will consider that two arguments were given, /var/log and the file, and will try to remove them both. So instead of removing that specific file, you could remove the entire /var/log directory, which will break your entire system. Such a mistake is avoided if you always use tab completion. I hope that this lecture has provided you with a good understanding of how tab completion works and how to properly use it. By default, the history command will display the output as the number of the command in the history and the command. This command didn't display at what time the commands were executed. For auditing purposes, it may be helpful to display the timestamp along with the command. To solve this problem, we'll set the environment variable called hist time format like this. Hist time format, written in uppercase letters, equals, and between double quotes, the following string. %d, a /, %m, another /, %y, a white space, and %t, capital T. %d represents the day, %m is the month, %y the year, and %t, capital T, the time. Of course, you can format it any way you wish. Now, let's run some commands, and then the history command again. And I'm running the history command. And we see date and time information attached to each command. In your case, before setting the hist time format variable, no time information was recorded in the history, so it couldn't know at which time those commands were executed. The history command is displaying the time the hist time format was set for all those commands. So for all commands, run before setting the variable. In my case, you see the date and time information for all the commands because before recording this video, I was playing around with the variable. If you want the setting to be persistent after system restarts or the user logs out, you need to add it in the .bashrc file. So echo the command between double quotes, 2 greater than signs, and the file .bashrc. Let's see the file. Okay, the setting is there. From now on, it will record date and time information for all commands. Let's talk about Linux users, one of the key concepts in Linux. On each Linux system, there are two main categories of users: non-privileged users and root, which is also referred to as the superuser or the administrator. Root exists on any Linux system. Root privileges are the powers that the root account has on the system. The root account is the most privileged on the system and has absolute power over it. Among its privileges are the ability to run any command or to access any file on the system. Actually, it can do anything on a Linux system, such as installing a new software or updating the existing ones, setting up the network, changing the ownership of files, managing other users' accounts, or administering any service that's running. On the other hand, all other users, which are called non-privileged or normal users, have no special rights on the system. They can only work in a directory called user home directory and cannot perform any administrative tasks like installing new software, creating other users, or running administrative commands. Because root is so powerful, it's not recommended to use it for ordinary tasks such as browsing the web, writing emails, or documents. Even a simple mistake, like for example a mistyped command, can cause problems to the entire system. So, for ordinary tasks, it's highly recommended to use a normal user account. And when root permissions are needed, you simply become root only to perform that particular administrative task. On many Linux distributions, like those based on Debian or Ubuntu, the direct logging in as root is prohibited. Let's see how to gain root access in the terminal. There are more approaches and I'll show you all of them. The first way to temporarily become root in a terminal is to run sudo su. By the way, sudo stands for superuser_do and su stands for substitute user. It's asking for the user's password. Note that this is not the root password, it's the non-privileged user's password that ran the command. I'm entering the password, and if the password is right, and the user is part of a specific group which is called sudo on Ubuntu and will on CentOS, then a new shell with root privileges starts and the user can run their administrative commands as root. You can say that you've temporarily become root in that terminal until you log out from it. To see the user you are currently logged in, run the id command. This command prints out the logged in user and the groups it belongs to. To log out, you type exit or press Ctrl and D. Note that when becoming root, if you add a white space and a hyphen after su, then the root working environment is activated. The current working directory was changed to the root home directory. This executed all of the root user's shell initialization scripts and set all environment variables as if the root user was logged into a fresh shell session. By convention, on Linux all users' prompt ends in a $. Root is the exception as its prompt ends in a hash. A second way to run commands as root is without logging into the root account, but by using the sudo command and the command you want to run as root. If you prefix a command with sudo, you are prompted for a password, not the root password, and if your user belongs to a specific group, sudo on Ubuntu and will on CentOS, the command will run with root privileges. Let's see how this works. I want to run an administrative command that creates a new group. If I run it simply by typing the command, I'll get a permission denied error. Only root is allowed to run the group add command and create a new group on the system. I'm simply running the command. And I've got a permission denied error. Now let's write sudo before the command name. And the command was executed successfully. A new group was created. Note that I'm not logged in as root, but as the initial normal user. I'm student. Using sudo makes it much more difficult to forget that you are root, since you are not logged into the root account and you don't need to log out after you've finished your job. Let's try to run a second command as root. This time, I'm gonna create a new user on the system. Sudo user add John. And you notice that the command ran as root without asking for any password, as in the first example when I ran the sudo command. That's because the sudo policy caches for 5 minutes the credentials I've entered in the first place, and anytime I run the sudo command, the timestamp is updated to 5 minutes. In this example, after I ran the sudo user add command, I could run other commands as root without being asked for any password for exactly 5 minutes. By running sudo with the -v option, a user can update the cached credentials without running a command. And if I want to invalidate the user's cached credentials, I need to run sudo -k. In other words, the next time sudo is run, a password will be required. Let's create a new user. And a password is required. The last method of running commands as root is to temporarily become root in that terminal by running the su command and entering the root password. Note that on some distributions, like Ubuntu-based, this method is by default disabled because direct access to root is locked. Remember that you have installed Ubuntu in the first place without setting a password for the root account. To unlock the root account on such a distribution, you simply have to set its password. Note that not having a password doesn't mean that without it you can log in as root, but on contrary, it means that you cannot log in at all. I'm setting the root password. The command used to change a password in Linux is PA_SSWD. So sudo PA_SSWD and the username, root. It's prompting for my password so that the command will run as root. I'm entering my password. And now the new password for the root account. I enter it 2 times. Note that on Linux, when you are entering a password, it doesn't display it. It's a security measure so that no one can find out how long the password is. Type the password even though you don't see it. Now, I can temporarily log in as root by running su and entering the root password. So su, and I'm entering the new root password. And I'm root in this terminal. This method of becoming root is available only in a terminal. You are still not allowed to log in as root in the graphical environment. On CentOS, this method of becoming root is by default available, and the root password is the one you've set at installation time. I am entering the root password. And I'm root. Note that a user can change its own password by running the password command, and root can change the password of any user by running the password command, and the username whose password will be changed. Root is changing the password of a user called student. The password shouldn't be shorter than 8 characters. That's all. You've just learned how to run administrative commands as root in Linux. At the end of this lecture, I want to clear for you that the word root has also several additional related meanings when used as part of other terms. This can be a source of confusion for the newcomers to Linux systems. Let me give you some examples. One of the most frequently met terms is the root directory, which is the top-level directory of any Linux file system. All other directories and files reside in this directory. The root directory is designated by a /. This is the contents of the root directory. Another term is /root. This is the root user's home directory. A home directory is the primary directory of a user's file, and it's actually the directory in which a user finds itself when it logs into a system. /root is a subdirectory of the root directory as indicated by the / at the beginning, and it should not be confused with that directory. This is root, and this is /root. Home directories for users other than root are by default created in the /home directory, which is another standard subdirectory of the root directory. This is where the home directories of the other users are located. Let's suppose we want to run a command that shouldn't be saved in history. For this example, I'll use wget and download a file locally. And I'll download the logo image of Google. This one. Copy image location, and in the terminal, I'm writing wget, and I'm pasting the contents of the clipboard. The file was saved locally in the user's home directory. This is the file. Now the admin or other users that have access to this account can see the command I've run by executing history. What can I do? If I erase the history by running history -c, it will look suspicious. Why would someone erase his entire history? If you manually edit the history file, the command that opens the file for editing will be saved in the history as well, and it's not good. This will be saved in the history. It's not good. A possible solution is to type a space in front of a command before running it in the bash shell, and the command will run normally but won't appear in your history. Let's do it both on Ubuntu and CentOS. I'm running the who command, which will display the users logged into the system. And I'm checking the history. And of course, the command is there. Now, I'll write a white space and the command again. And I'm checking the history. And the command was not saved. who-a was not saved. Let's do the same on CentOS. I'm writing a white space and the command. And I'm checking the history. This time the command is there even though I've added a white space before the command name. So we see that the behavior is not the same on different Linux distributions. Let me tell you in detail how that works. There's a special variable called hist_control that allows you to ignore commands and not save them in bash history if you set the variable to ignore space. Lex CX value on both Ubuntu and CentOS. Echo, a $, and the variable name, hist control. So, hist control is set to ignore both on Ubuntu. And now on CentOS. Don't forget to write a $, before the variable's name. On CentOS, the variable is set to ignore DAPS. Let's set it to ignore space on CentOS. Hist control, written in uppercase letters, equals ignore space. Ignore space, written in lowercase letters. Now, I'm running a command adding a white space before its name. Let's check the history. And the command was not recorded. But what will happen if I run the same command multiple times? Will it record each command or ignore duplicates? I'm running the cd command multiple times. 5 times. And I'm listing the history. We see that it has recorded each command, which maybe it's not what we really want. Maybe you want your history a bit cleaner by ignoring duplicate commands that can clutter it. You can set the hist control variable to ignore DAPS, which stands for ignore duplicates, the way the default in CentOS is not to save duplicate commands in history. So I'm modifying the variable. Hist control equals ignore DAPS. Ignore DAPS written in lowercase letters. And I'm running another command multiple times. Let's see the history. It was saved only once. Now to use both the ignore space and ignore DAPS features, set the hist control variable to ignore both like is the default in Ubuntu. It will save nor the commands that are prepended with a white space, neither duplicates. Note that bash variables you set will only persist for the current session. After you log out or restart your system, the settings will be lost. To save the settings after the system reboots or the user logs out, you have to add the settings to that bashrc file in the user's home directory. We'll talk more about that when we discuss editors and bash scripting. For the moment, the easiest way for you to do that is by running echo, the setting you want to save, hist control equals ignore both, double greater than symbol, and the path to the file, .bashrc. This command has appended this string to the end of the file.